Please subscribe and do not forget to click the bell icon so that you can always stay connected with Nakoda Education and Home Tutors.
Now we are done with the chapter. Now let's start with the exercise. So the first question in the exercise is study the entries in the following table and rewrite them putting the connected items in a single row. So that is, you just have to match the following. So the first entry which is given here is mass meter per second square and 0 at the center, which is incorrect. Mass is measured in kg and it is the measure of inertia. Next is weight, unit of this is measured in Newton and it depends on height. Then acceleration due to gravity, which is the unit is meter per second square and it is 0 at the center. And the last is gravitational constant, that is the unit is Newton meter square per kg square and it is same in the entire universe. Second question in the exercise is answer the following question. So the first question under this question is what is the difference between mass and weight of an object, and will the mass and weight of the object on the earth be same as their values on Mars and why? So the first क्वेश्चन में आपको क्या एक्सप्लेन करना है, मास एंड वेट जो है इनके डेफिनेशंस आपको बताने हैं. दैट मास इज द जस्ट द मैटर विच इज प्रेजेंट इन द ऑब्जेक्ट, सो मास कंसिडर किया जाता है. वेट जो है दैट इज द फोर्स विथ विच अर्थ अट्रैक्ट्स इट टुवर्ड्स इटसेल्फ, दैट इज द वेट. Now the next question is will the mass and weight of an object on the earth be same as their values on Mars? So no, mass जो है वो सिमिलर रहेगा, जो भी मास अर्थ पे रहेगा सेम मार्स पे उतना ही मास रहेगा, बट जो वेट है दैट विल बी चेंज्ड. अर्थ पे जितना वेट है कंपैरेटिवली मास पे जो वेट रहेगा दैट विल बी चेंज्ड बिकॉज ऑफ ग्रेविटी. Because the value of G on the Mars is different than the value of G on the Earth and that's why it will be changed. Next question में आपको definitions पूछे गए हैं free fall, escape velocity, centripetal force and acceleration due to gravity. So you just have to define these terms. Third question is write the three laws given by Kepler and how did they help Newton to arrive at the inverse square law of gravity. That is, ये जो inverse square law है, that is the force is inversely proportional to 1/r square. So इसमें आपको क्या करना है, जो केपलर्स के 3 laws है वो एक्सप्लेन करने हैं, तीनों के तीनों लॉ विथ डायग्राम, एंड देन आपको एक्सप्लेन करना है कि न्यूटन ने इनवर्स स्क्वायर लॉ ऑफ ग्रेविटी कैसे डिस्क्राइब किया. दैट इज F is inversely proportional to 1/r square. This is what you have to explain. Next question is a stone thrown vertically upwards with initial velocity u reaches a height h before coming down. Show that the time taken to go up is same as the time taken to come down. So we have v is equal to u plus at and s is equal to ut plus 1/2 at square. Now u is equal to v minus at, so here we will write down, therefore s is equal to v minus at and this t is here plus 1/2 at square, that is Pt minus at square plus 1/2 at square. Therefore S is equal to Vt minus 1/2 at square. This is the first equation we have derived. Now I've drawn a diagram here, that is a stone moves from A to B and from B to A downward direction में. So as stone moves from A to B, A to B, then S is equal to AB, that is height. T is equal to T1, time taken to stone to reach from A to B is T1. Then U is equal to U, that is the initial velocity is U, and B is equal to 0. Then acceleration, A is equal to minus G, that is retardation. So from this equation first, H is equal to, we are just substituting the values here, 0 minus 1 half AT square. So A is minus G and T square. Now T is T1, so T1 square. Therefore H is equal to 1 half GT1 square. As the stone moves downward from B to A, then the values will be, this is the second equation. As the stone moves downward from B to A, then T is equal to T2, U is equal to U, S is equal to H, and A is equal to G. Then from this equation we can say that H is equal to 1 half G2T square, GT2 square. So this is the third equation we have derived. So from these two equations we can say that T1 square is equal to T2 square, that is T1 is equal to T2. Hence time taken for stone to reach from A to B and B to A is the same. Next question is, if the value of G suddenly becomes twice its value, it will become 2 times more difficult to pull a heavy object along the floor, and why? So the first point in this is, to pull an object along the floor, it is necessary to do work against the force of friction, between the object and the surface of the floor, And this force of friction is proportional to the weight of the object. So this force of friction is proportional to the weight mg of the object. Now, if the value of G becomes twice its value, the weight of the object, and hence the force of friction will become double. So, if the value of G becomes twice its value, the weight of the object, and hence the force of friction will become and therefore it is difficult to pull a heavy object along the floor. Next question is, explain why the value of G is 0 at the center of the earth. Now we know that the value of G changes while we go inside the earth, dip inside the earth, and it goes on decreasing as we go from the earth's surface towards the earth's center. Now we shall treat the earth as a sphere of uniform density. If we consider the particle of mass m at point P at a distance r minus d from the earth's center. I have drawn a diagram here, that is particle at a point P from the earth's center at distance r minus d. So here r is the radius of the earth, d is the depth below the earth's surface. The gravitational force on the particle exerted by the earth is equal to, that is force is equal to gmm upon r minus d square, where this m is the mass of the sphere of radius r minus d. Now, so we have just derived the formula here. So mass is equal to 4 by 3 pi in bracket r minus d cube into m upon 4 by 3 pi r cube. So here we get m in bracket r minus d cube upon r cube. Now this is because the outer spherical shell, is not effective, and in this case the acceleration due to gravity is, so the acceleration g is equal to f by m is equal to g upon r minus d square into m into r minus d cube upon r cube. So the value is gm in bracket r minus d upon r cube, where m is the mass of the earth. Thus the G decreases as the D increases. Value of G decreases as the value of D increases. So it is less than that at the earth's surface, that is gm upon r square. At the earth's center, D is equal to R, and therefore G is equal to 0. And that's why the value of G is 0 at the earth's center. The next question is, let the period of revolution of planet at a distance r from its star be t. Then prove that if it was at a distance of 2r from the star, its period of revolution will be square root of 80. So here t is equal to 2 pi upon square root of gm into r raised to 3 by 2, where t is the period of revolution of a planet around the sun. M is the mass of the sun, g is the gravitational constant, where r is equal to radius of the orbit assumed to be circular, that is distance and that is distance of the planet from the sun. So for r is equal to, small r is equal to capital R, and t is equal to t1. Then t1 is equal to 2 pi upon square root of gm into r raised to 3 by 2. If we have taken r is equal to 2r and t is equal to t2, then t2 is equal to 2 pi upon square root of gm into 2r raised to 3 by 2. That is 2 pi upon square root of gm into r upon r raised to 3 by 2 into 2 raised to 3 by 2. So अगर values निकालते हैं, then t2 is equal to t1 in the square root of 8, that is it is square root of 80, and hence it is proved that if we have taken 2r, if the planet is placed at a distance 2r from the sun, then the period of revolution will be square root of 80. Next question जो दिया गया है, that is solve the following examples. So numericals दिए गए हैं. First what you have to do is write down the given things, then write down the formula which is related to that question, substitute the values, and आपको answer निकालना.